section, we can calculate the current in a single loop circuit. As we know from chapter 26, I, or current, equals dq over dt. If you solve for dq, you see that dq equals I dt. The formula that we just introduced in this last section is EMF equals dW over dq. So you can substitute this equation into here to see that EMF equals dW over I dt. Then solving for dW, we have that dW equals EMF I dt. So this is an equation that can stand on its own, but we can also use it to derive even more formulas. So as we know from chapter 26, the thermal energy is the work dissipated from the circuit, and that has to equal the work done in the circuit. So the formula for the work dissipated is power equals I squared R. So as we know from last year, power is work over time. By taking the derivative, we can then see that power also equals dW over dt, or the change in work over the change in time. So solving for dW, we see that dW equals P dt. So we have a dW and a dW here, and then these two are both include power. So to have this power equation equal dW, we need to multiply it by a dt. So dW equals I squared R dt. Now we have this equation which equals dW, and this equation which equals dW, so we can set them equal to each other. Therefore, EMF I dt equals I squared R dt. As you can see, we have a couple common terms, so we can cancel out the dt's, and we can cancel out this current and one of the currents here. So, EMF equals IR. And solving for current, we finally see that I equals EMF over R.
Okay.